Hi and welcome to this presentation. My name is Joachim Beck, and we will give an introduction to you about Keymaster and Gatekeeper. I also have Victor Chong here. He will take the second part of the presentation, more how you actually working with Keymaster. So what is Keymaster? So that's a way where you can use hardware-backed security for storing keys and IDs like IMI, serial numbers and such. So it consists of a couple of components, the features that we can see here. So you have the access control of the keys. That is something that you specify when you generate the key, so it could tell who can access it, for how long is it valid, and so on. You have the version binding, which is basically rollback protection. So if you find some old software that could have a flaw, you should not be able to just reload the old software. And this is tied to the patch level on the operating system. Yeah, and I also think that in the later versions they have split up the complete binary, so now it's patch level for system image and other images also. Client binding is when you have a certain key that should be associated with a client application. So a normal Android app should be able to have its own unique key that is defined here. Expiration, well, it's what it says. How long should this be valid? Velocity is basically that you delayed the time between each and every try you do. So you should not just be able to brute force it, since you have to have more and more time between each try in this case. Then we have the root of trust binding. So every single key that you generate should be tied to the root key in some way. Attestation, so this I would say is probably the big thing with Keymaster. You need to have a way to ensure that the keys that you're using is actually stored in hardware. So by using certificates with all the information, you can verify that the key that is going to be used is actually stored in a hardware-backed environment. And all this is based with what is called authorization tags. So that's basically a set of structures and so on that is tied together here to make it work. And starting from Android O, this is something that's mandatory. Gatekeeper, on the other hand, I have some more slides later on showing how it looks in architectural overview. Gatekeeper is the one that is responsible of enrolling, basically registering passwords and verifying passwords. So when you're entering the PIN code, for example, on your phone or dragging the finger, you have the gatekeeper involved in that. So if we look at the architectural overview, you can see that if we take Gatekeeper in this case, for example, you enter your password. The daemon in a normal world user space will take care of it and send it down to the Gatekeeper TA in this case. The Gatekeeper TA will sign a message and send it back to normal world user space, which then will talk to the Keymaster, and the Keymaster will verify that it was okay and then opens whatever feature you were trying to access. Fingerprint, we haven't really touched that, so I will not really say anything about it. But it could be in the future that we will also start looking into the fingerprint reader. And this is the view of how things are looking from OpT point of view, where we're doing the work right now. So on the left side, you have the RE, as usual. On the right side, we have the trusted side. And you can see on the top in the user space, we have the Keymaster and Gatekeeper blob. And that's basically the things that are running in AOSP. So they will be in AOSP forest in this case. On the right side, you have Keymaster as a trusted application. We have, as it looks today in implementation, we actually have some parts in privilege mode also that are used with the Keymaster TA. But that is something that we're going to refactor a little bit and move it up to the Keymaster TA only. And from AOSP point of view, this is how it looks like. So all the messages, I mean, lock settings, for example, in this case, from the pin. When you enter the pin, it goes down through the HAL, and we're starting to execute our code in the first blue rectangle here, so that's the Gatekeeper HAL. And then, just as the two previous slides, you go down to the T itself and execute the code. So when we were going to start from this, we had it on our roadmap, but we have started to work with PKCS11 related functionality also. Initially, we were believing that we should be able to maybe combine these two, but when we had to start to look into it, we realized that they are two separate. So let's do it one by one instead. We had, well, it took precedent. The PKCS11 work was the one that we spent most of our engineering time on, so we got a little bit delayed by that, and we also had some Spectre and Meltdown stuff, so we were kind of a little bit short on manpower basically to start working with this. Not until May last year we started to ramp up in full speed. We were a couple of 3-4 engineers working with it almost full time, I would say. But we started from scratch, and we had quite a few open questions. And in June, there were one company reaching out to us and saying, we have a solution working that we can give to you. So we start to think, what should we do now? Should we try to merge what we have done so far together, or should we throw it away? Or, yeah, what should we do? So we decided to try it out. I mean, have a look at the code, do some sanity testing and so on, and it seems to be pretty good. So we decided to go with the code that we got donated to us. So we just throwed away everything we've done and started with this base instead. And that is the code base that we have been working with now since the summer, and trying to integrate it in a high-key device, on a TI device, and so on. And trying to fix a couple of pending issues that we have seen also with the VTS test cases. And we have started doing some refactoring already also, and cleaning up for upstream, since we would like to submit this to the AOSP forest and get it merged properly, so to say. All the test cases were passing. There is a star there. When we upgraded to a newer version, we got 2 regressions. And those are the ones that we're fighting with right now, but I think we know what the issue is. We have also started to create a stable manifest, so other people can try our things out. It will need to be based on forks, since we haven't been able to upstream everything. And we also need to have the support from Google in this case, so they accept the code from us. And what I mentioned already is about this refactoring of the code. It's removing the, as I said, on the right side here, I mean, on the privilege mode, we are going to remove the pseudo TA that we have there and move it up to the Keymaster instead. Yeah, I think that's my part. So now I hand over to Victor instead, to a little bit more hands-on how you can use it.
Hi. So if you wish to try this out, the way to build this is just clone this GitHub repository that we have created for you with the just checking out the YVR18 branch. Just CD to the T-Android manifest directory, and then you can just run a sync script and a build script. So previously, we had to build everything manually, but we've created the scripts just to simplify the building for you. So once you're done with the build, this is the standard procedure for flashing the images to the high key. With the AOSP build, there's a flash all script under device Linaro high key. So if you want to use that, you can. Otherwise, you can just flash using fastboot manually. Okay. So to test this, you just execute ADB root and then run the VTS test suite. We're not running it through the VTS interface, so we're just running it as the gtest standalone unit. You just, with the path to the executable, it's just data native test 64 VTS HAL Keymaster. So you just run it. The test takes quite long to run, maybe about an hour. So if it's a test suite consisting of about 106 tests. So if you want, you can filter it out and just run, individual tests, set of tests. You can do wildcards. And just with the -- help tag, you can see the list of options that you can use for filtering or positive or negative matches. And just a note that this is because since we're still working on development, this is sort of a debug build, so there'll be very verbose printout. So just FYI, in case you don't like things scrolling up your screen too much. Okay, and with this build, there was an issue with the hardware composer service failing to start, so that sort of clutters the console. It's not really an opti issue, so we have a workaround for this. It's basically, we just delete the service file for the composer, and then it stops it from starting. But I think that's fixed by the Android team now, so if you need to, just let us know. We can give you the patches for the fix. And then if you don't like building, we have pre-built binaries as well, so you can just go ahead and download this, flash it to your board, and just run it, test it, see how it works. And then if you are just working on the Keymaster Gatekeeper application alone, this might be easier because you don't have to build the full AOSP build. You can just build your executable, build your trusted applications, and just ADB push it to replace whatever is in here. So that makes things a lot easier and save you a lot of time. So this is the sample test output. So once you, from running this ADB shell command, it will just go through all the tests in the test suite. And then you should see this. It says, 106 tests from 12 test cases, and gives you a total time. I haven't actually calculated that, but it should be about an hour. So this shows that all the tests passing. So that's all we have for now. Our next steps will be just which I think Igor, one of our engineers is working on, is to refactor the pseudo TA into dynamic trusted applications so that we can just have everything contained within TAs. Improving SE policies, because at this point we have to run everything as root, so we like to be able to run it as a non-root user as well. And then upstreaming, we're in contact with the AOSP people to see what is the best excuse me, the best approach or strategies for getting all this upstream. And Keymaster version 4 was released not too long ago, maybe several weeks ago, so that's another thing on the list to watch out for, to see if we can upgrade the current version 3 from 3 to 4. And then lastly is the fingerprint daemon. Might be something to look at as well. I think that's it. Any questions?
I'm wondering what is required to support this on the new platform?
The code is platform dependent, so you can just take it, just put it on a platform and build it, because it's platform independent.
So it means it mainly depends on Opti, like the all layer only depends on Opti specific implementation?
Yes, so you already have Opti on your platform, right, I believe. So yeah, just take the is this. If you take the manifest, you can see what's needed, and then you can just take it and, but basically it's just, there are some patches on OptiOS that you'll need. But other than that, the Android userland stuff is in a separate repository. I can give you the link later. You can just take it and compile it and just try to run it.
The only dependency I think I can see is that you have to tie things to the hardware unique key. So depending on your hardware, you need to figure out how you are using the hardware unique key on your hardware. Otherwise, I think it's like we said, pretty device independent. It's just software running. Submit.
As Joachim, you showed in the earlier slides that you are trying to link that passcode storage with this. So is that linked with this applications? Is there any demo application where you enter your PIN and that gets stored in the secure storage provided by Opti?
No, there is no demo application yet. I don't think you see any graphical when you're running VTS and such. It's just console-based everything.
Yeah, the thing that I guess we and probably most people go by is the VTS test suite, because it's tests for everything that's implemented. So there is a GUI interface to VTS, but we've never used it. It seems like it's.
I think that would be a good demo for.
I mean, in theory, if it works in the VTS test and you would apply it on an Android device and you have the login dialog, then in theory it should work.
Okay.
I have pretty much two questions. First, how is this TA signed? I know that TA should be signed, and is this signature integrated into your script? And what keys? Just like, everyone can download your repository and build it and sign, and it should work?
Yeah, so since this is a public tree that we have hosted on GitHub, you can of course not have all the keys and such. So what we have there today is a development key. Private key is there. So, but of course you as a SSE vendor are supposed to replace that with your own key. And when you've done that and you have compiled your TAs, if you use the same way of building as we are, it will be signed for you automatically. And when you're loading the TA, T-Core will verify the signature before loading and running the TA itself.
Okay, thanks. And the second one, have you considered the situation when you have Gatekeeper and Keymaster in a single trusted application?
We talked about it 20 minutes ago, just briefly.
Well, no, but I mean, I guess it's possible, but I mean, it would help, I guess, in the case where, because we have to share the auth token HMAC key. So right now we're just using TA to TA communication, but if it's combined, then we don't have to do the extra. But I mean, they are sort of different features, different functionality, so it makes sense to just keep them separate. So.
Such design. So, I mean, just
What the profit? Well, the first thing as for me, you're not gonna to upstream to trusted application and trusted applications, and you will have in one repository all the code. That's the first, and the second one, this thing with HMAC key, and I'm pretty sure that you might have used some source code which is common for Keymaster and Gatekeeper, some functionality. And I just was wondering have you considered this option, and maybe you just thought about it and decided that not our case.
Yeah, no, to be honest, we haven't discussed it, but I mean, of course it's possible to do it. And if you find that there are bigger pieces of the code that can be shared, and well, it might be something that we could look into and consider, but so far not.
Thank you.
Okay. Out of questions?
No, we're good.
Okay.
All right, thanks for coming.
you.
Enjoy your day.